Hi, this is Lisa. In this video, we're going to talk about how to factor some special products. So we're going to start with multiplying out conjugate pairs so that we see what kind of a polynomial we get. Conjugate pairs mean the first term in each parenthesis is the same and the last term in each parenthesis is the same. So in this, our first terms are x and our last terms are y. And the difference that we have, what makes it a conjugate pair, is that in one parenthesis we have a plus and in the other parenthesis we have a minus. So our signs are different. So let's look at what happens when we do our FOIL here or multiply out using the distributive property. X times x is x squared. X times minus y is minus xy. Y times x is plus xy. And y times minus y is minus y squared. Notice our middle terms cancel out. One is a positive and one is a negative. So what we're left with is x squared minus y squared. This is also referred to as a difference of two squares. We have x squared and y squared, and the difference part means we're subtracting. So this leads us to a nice method for factoring a difference of two squares. Again, we're going to go back to the idea that a difference of two squares will always factor as a conjugate pair. So the first thing we want to do is identify the two squares. What is the first thing that's being squared minus the last thing that's being squared? And we're going to write the factors as a sum of what's being squared times the difference of what's being squared. In other words, we always do, as we started with in this example, we said we have the same first term, we will have the same last term, and the difference here, what makes it a conjugate pair, is that one is a sum and one is a difference. So let's look at some examples. Example number 1 says we have x squared minus 16. The first thing that I'm squaring is the x. Minus, I do have a difference here, and 16 can be rewritten as something squared. So that thing that we square to get 16 is 4. So I do have something squared minus something squared. My method for solving says we're going to take the first plus the last, the first minus the last. Always one plus and one minus. So here the first thing that was being squared is x. So that goes in the first spot in each of my parentheses. The last thing that was being squared is 4. So 4 goes in the last spot in each set of parentheses. And you can always multiply this out to check. So if I do a FOIL on this, I'm going to do this in red. X times x is x squared. X times minus 4 is minus 4x. 4 times x is plus 4x. And 4 times minus 4 is minus 16. Notice my middle terms cancel out. Negative 4x plus 4x is 0. So I have x squared minus 16. That's the polynomial that I started with. So I know that I factored correctly. X squared minus 16 is equal to x plus 4 times x minus 4. I'll do a few more examples. 81x squared minus 25. I always start the same way. Can I write this as something squared minus something squared? 81 is a perfect square. 9 times 9 is 81, so I can write this as 9x. When I do 9x times 9x, I get 81x squared. And 25 is a perfect square. 5 squared will give me 25. So again, I'm looking at what's the first thing I'm squaring, what's the last thing I'm squaring. I have 1 plus and 1 minus when I factor. The first thing is 9x. That goes in the first spot in each parentheses. And the last thing I'm squaring is 5. That goes in the last spot in each parentheses. 49x squared minus 9y squared. Can I write it as something squared minus something squared? 49 and x are both perfect squares, so I have 7x. 7x times 7x will give me 49x squared. 9 and y squared are both perfect squares. So I want 3y quantity squared. 3y times 3y will give me 9y squared. So again, I set up my parentheses, one with a plus, one with a minus. Doesn't matter whether you put the plus or the minus first, as long as you have one of each. First thing we're squaring is 7x. That goes in the first spot in each parenthesis. Second thing I'm squaring is 3y. That goes in the last spot in each parenthesis. And I have one more example here. X squared minus 6 squared. Can I write this as something squared minus something squared? X times x is x squared. But 6 is not a perfect square, so using this method over the integers, this cannot be factored. Because I cannot write 6 as something squared. And a sum of two squares is always prime unless there is a common factor. So if I look at this example, x squared plus 25, this is a perfect square, 25 is a perfect square, but I have that sum in the middle. There's no way that I can do this over integer values where those middle terms will cancel. So this one is prime. In other words, it cannot be factored. And likewise, 4x squared plus 16y squared, the only way I can factor this is to recognize that this is 4 times x squared, and 16y squared can be written as 4 times 4y squared. So I do have a common factor of 4, and then x squared plus 4y squared. Again, I have perfect squares here, but that sum tells me it cannot be factored any more than that. The only thing I could take out was that greatest common factor. And that concludes the video on factoring a difference of two squares.